Due to high emission and dense traffic in the cities, there is a strong interest in a modal shift towards waterborne transportation. In cities with dense waterways, this alternative could be provided. However, it increases the demand for trained captains and ship crew, professions which are in continuous decline in Belgium and the Netherlands. Smart Waterway aims to solve these problems by bringing low-cost autonomy to small pallet shuttle barges. These vessels are smaller in size and thus navigable in urban waterways. Using low-cost sensors and equipment, we aim to provide a cost-effective solution for situational awareness, communication, and accurate positioning. We designed and field-tested a semi-autonomous solution for pallet shuttle barges with low-cost sensors, including LiDAR, camera, GNSS sensors, ultra-wideband positioning nodes deployed both on the shore and on the barge, and CityMesh Nova nodes. IDLab designed a situational awareness system on top of low-cost sensors, including LiDAR and camera. An AI-driven obstacle detection and localization system was designed to create real-time dynamic maps of the environment. We also designed a collision avoidance and real-time path planning system on top of reinforcement learning to navigate the vessel in the inland waterways. Along with Seafar, we had a detailed feasibility testing of collision avoidance and simulation. To ensure reliable communication, an ultra-fast and resilient communication solution was deployed on the vessel by CityMesh. It used several enterprise VPNs that tapped into the bandwidth of the 4 Nova nodes, with public 4G, private Wi-Fi, and private 5G. Pozyx, along with IDLab, designed new angle of arrival antennas to enable a reversed positioning protocol in which the fixed nodes on the canal banks were simple and battery-powered. All of the research in Smart Waterway was validated on a vessel within the waterways of Ghent. IDLab demonstrated active path planning in the narrow waterways, while the vessel's positioning and heading was calculated by Seafar. Seafar also deployed GPS antennas at the front end of the vessel, while IDLab developed a smart path planning module which provided routes along with speed, course, and remote teleoperation handover recommendations. Using the reversed ultra-wideband positioning protocol with simple battery-powered nodes on the canal banks, an advanced angle of arrival node connected to the positioning server on the barge was accurately positioned while passing under the pedestrian bridge at the crook. CityMesh deployed 2 private networks along the vessel route. The first network was a private Wi-Fi network located at the start of the trajectory. The second was a fully developed private 5G network located at the end of the route of the vessel. Based on vessel position, we selected the best performing connection, providing connectivity without any service interruption or degradation. Finally, IDLab tested offshore cameras for traffic density prediction along the canals. All the boats and ships that passed through the camera were correctly detected. This information can be used for long-term planning and to anticipate approaching vessels beyond the line of sight of the autonomous barge, avoiding potential collisions. The Smart Waterway solution showed that autonomous pallet shuttle barges appeared to be the cheapest option for the vessel owner. Furthermore, switching to pallet shuttle barges from trucks would yield an annual total external cost reduction of 76%. With this, the net benefit for all the actors appear to be favorable, hence justifying the use of pallet shuttle barges. Smart Waterway achieved a proof of concept for an autonomous vessel system in inland waterway, and it has resulted in numerous interesting findings that can be subject to future developments to achieve safer operation and full autonomy in inland waterways.